Welcome to the MIA Internal Communication module. I'm Pete Wolf, the Sioux in Jacksonville, Florida. Unlike the other modules in the MIA Communication section of Part 2, which mostly focus on external communication with partners, this very short module focuses on internal communication between the Mesoanalyst and the Warning and IDSS staff members during a high-impact event. The objectives of this module include describing the importance of good internal communication of science between the Mesoanalyst and Warning and IDSS staff to support good internal decisions, illustrating the characteristics of good internal MIA communication and what to avoid, and describing the best tools for internal MIA communication, especially for remote mesoanalysis. This module will refer to both on-site and remote mesoanalysis communication. I want to point out, however, that while what is best for remote communication is still being evaluated as of the day of module design, best practices with technology presently available will be the focus here. Recall that the National Weather Service priority of operations has warnings at the top, followed by aviation forecasts and so forth. That continues to be the case today. However, in our IDSS evolution, based on the value of information for our mission, I would place IDSS messaging at the top. The problem with what is shown here is the fact that something important is missing. It doesn't matter if you have a good means of communication if you don't have good information to communicate. Warnings are of little value if not backed by good science. So see, science is what's missing. And that involves mesoscale environment analysis. A quality severe storm program requires all three to be linked together, with science supporting accurate warnings, which are communicated to customers. Additionally, science is important for generating quality threat messaging for partners. So it doesn't matter how good the result is from science if you don't have a good means to communicate that information. And it doesn't matter how good your communication is if you don't have good information to communicate. All three must work together. So in this module, when it comes to MIA internal communication, what should the Mesoanalyst communicate to other key staff? It is tempting to focus on just your expectation of what's most likely to occur. However, at times, warning decisions and IDSS threat messaging must lean toward a worst-case scenario. Not necessarily the absolute worst case, which is extremely unlikely to occur, but perhaps the reasonable worst case. For example, looks like the storm will produce golf ball-size hail, but if the detected rotational signature intensifies, we could see tornadogenesis happen. The expected weather should lead to a severe thunderstorm warning, while the reasonable worst case could support a tornado possible tag within the warning, and a mention of possible tornado in IDSS messaging. How would you answer this true or false question? The Mesoanalyst can help the Warning and IDSS team prioritize actions to be taken based on storm threat intensity or severity and the areas threatened. That answer is true. Yes, the Mesoanalyst can help the team with respect to prioritization, particularly when there are numerous intense storms detected by radar. In addition, the Mesoanalyst can provide information to help the team downscale and enhance the information provided for a given storm or threat. How about this question, true or false? When known, the Mesoanalyst should indicate to the team what warning type needs to be issued and what specifically to state in IDSS messaging to partners. The answer to this is false. The warning person and the IDSS person are the event decision makers. They are the ones who make the decisions on products and messaging, not the Mesoanalyst. Instead, the Mesoanalyst should focus on providing information to the team that supports the best decisions possible. So this is important. Everyone has their role to play in operations. It's important not to cross the line and do someone else's job. The Mesoanalyst has an important role that helps the other positions achieve their tasks better. Take a look at this radar reflectivity image of an intense squall line that's covered by multiple large severe thunderstorm warning polygons. As the Mesoanalyst, in looking at the environment as well as the storm structure of the cells, you see three segments of the line that have suggestions of intense pressure perturbations supporting damaging winds. These are based on very tight leading reflectivity gradients with max values of 50 dBz or greater, along with decent cores aloft above them, which are not shown here. This information points to only three areas where we have the likely probability of damaging winds. The first is the Boeing segment heading toward Waycross, Georgia, which does produce wind damage southwest of Waycross. The second is in Eccles County, that does bring some trees down. and the third is just west of Suwannee County, which causes some damage in the town of Mayo. So should the Mesoanalyst focus on the larger scale, that being progress of the entire line of storms, or focus on downscaling to where the threat is most likely to occur and when, and provide that information to allow the IDSS person to provide targeted threat messaging to partners and the public? While both can be done, this course really focuses on the latter to provide higher quality threat information that, frankly, the warning text products don't provide. Therefore, how would you answer this question? What might be the best way to message the threats to your staff? In looking through the answers here, hopefully the correct one is obvious, and that is answer B. The best potential for damage appears to be with the Boeing segment approaching Waycross, another moving in eastern Echols County, and a third entering western Suwannee County. Expecting subsevere wind gusts elsewhere along the line where we lack a tight leading reflectivity gradient beneath a decent core. Why would C, focusing on smaller warning polygons, not necessarily be the best answer? It is not necessarily incorrect, but I would suggest it may not be the best answer for the same reason it's unwise to issue small warning polygons for individual pulse severe storms in the summer. One needs to account for uncertainty and what could change over the course of the warning period. A new pulse cell could develop just outside of the polygon in summertime, requiring another polygon. Likewise here, a new Boeing segment could develop during the warning period outside of these three areas shown, requiring additional warnings. If not careful, it can end up getting confusing for both warning person and customer. Given the very limited information the warning text really provides, let the warning do its main job of alerting people who are within the warning's area, and have the IDSS person focus on working with local media partners to accurately downscale the threat in time and space. Given the larger reach the media has compared to our websites or social media, such a partnership in providing targeted threat information rather than just generic warning information can be quite powerful. So what forms of communication are best between the Mesoanalyst and the Warning and IDSS staff members? When the Mesoanalyst is in the local office during operations, while obviously direct communication is best. While this is typically the best approach to incorporating MIA in operations, sometimes it may not be feasible, requiring remote MIA support from outside of the office or possibly from a neighboring office. For that, there are two primary options: a private chat room in NWS Chat and a phone call or Google Meet session. What is best is still being evaluated, and new options might become available in the future. As of the time of this module's design, NWS Chat private messaging is becoming a best practice, primarily because it doesn't lead to the distractions that phones and Google Meet can cause in operations. There's already enough stress and distraction sources in operations. We want to provide good near-storm environment information through a means that offers as little distraction as possible. The key word to focus on with respect to effective MIA internal communication is brief. You want to get to the point. In a high-stress environment, detail can get missed. You don't need to go into significant scientific detail, just the key points that back what you're communicating. Don't just focus on what you expect to occur. Lean your messages toward the reasonable worst-case scenario for the purpose of IDSS messaging. It's important also to be accurate and precise, and be careful not to contradict yourself in your communication to the staff. If you describe too many possibilities, it could end up getting confusing. I will now show you an example of internal communication between myself, serving as the remote Mesoanalyst, and our IDSS staff members who served as my points of contact, utilizing the IDSS-related information I provide, and sharing the warning-related information with our warning forecaster. This was a fairly fast-paced event across southern Georgia and northern Florida. The first part of the event focused on southern Georgia. Take a look at my first chat message at 12:39 p.m. Am I relaying information to support warning level threat information or subwatch or 1 to 3 hour lead time threat information for the IDSS person? Note that my focus is on the next 2-hour period as far as how this event is going to evolve. Am I focused on an overall CWA message, or am I downscaling to a particular county or even sub-county area during a particular time period? Again, notice at the end of the 12:39 chat, I'm focusing on the next 2 hours with a particular mesovortex that was detected and heading towards Clinch County, which is in the western part of our forecast area. After 1 p.m., I start shifting focus to warning level threat information. Here I am turning to the specific threats, in this case prioritizing on a potential window of opportunity for a more significant tornado to occur, with the environment information I'm providing aiming to boost our messaging. Notice not only the amount of communication taking place, but also the two-way nature of the communication. This can be done easily using an NWS Chat private chat room, which provides an audible alert for arriving messages. But it's not as distracting as constantly being on the phone or on a Google Meet session, with minimal sound to interrupt others in the office. Here we turn to the evening part of the event across northern Florida. It was a long event. I believe I spent about 10 hours in the remote Mesoanalyst role, and the work was almost continuous for much of that time. The tasks required and the time needed to complete them make it not favorable to combine the task with others in operations. Here again I start with messages focused on the sub-watch time frame. How is this event expected to evolve? What are the key threats and where? Information the IDSS person can use to provide targeted threat messaging focused on event evolution. Here I am still focused on event evolution and what to look at over the next hour or two as a QLCS approaches our western counties. Note that my chats are brief, to the point. It's okay to provide some snippets of science with regard to what you're looking at, but again, the key word is brief. After about 8 p.m., I start incorporating warning level information into the chats. Again, you can see considerable two-way communication, ultimately leading to more accurate, timelier warning issuances and IDSS targeted threat messaging for partners. The after-action review of this event pointed to the value of mesoanalysis in supporting a positive end result. This was seen in the event and the verification for the Jacksonville CWA shown in the oval, and the numbers, which were quite good: POD of 1.0, a false alarm rate at a reasonable 0.55, and excellent lead times in the 25 to 30 minute range, right where we want it. As you might suspect, this takes a lot of effort on the part of the mesoanalyst. Notice all the chatting in between, which I'm analyzing and QCing data and making determinations of what to communicate. The mesoanalyst role, done correctly, takes considerable time and effort, but the end result can be quite satisfying. So what good aspects of internal communication are seen from this example? You want frequent communication, and this can be challenging when you're involved in other tasks such as data analysis and QC. Two-way communication is important. You want to focus not only on what's expected based on what the environment supports, that is, the most likely scenario, but also what could occur if certain environment changes occur, a reasonable worst-case scenario. You want communication, of course, that gets to the point. Operations are busy, and it's important to get to the point on what you're saying. And finally, communication that supports specific decisions or messaging without specifically suggesting to issue certain products or messages. As you might guess, the challenge for the mesoanalyst involves time management. You only have so much time to get your task done, and therefore you need to properly balance your time for data analysis and QC with MIA internal communication. This is why it's unwise to combine the mesoanalyst position with that of others. Here's a brief summary of this module. Good internal MIA communication with your Warning and IDSS staff should focus on getting to the point, on two-way communication, on focusing on both expectations and reasonable worst cases, on providing information to support better internal decisions, but letting the Warning and IDSS staff make those decisions, and providing value without serving as a distraction, be it to yourself when you're also involved in data analysis, as well as to your team who are trying to make good and timely decisions. You have reached the learning assessment for this module. The assessment's not graded, it's simply provided for your benefit. For each question, pause the video as needed to come up with your answer and write it down on a piece of paper. Then continue the video to reveal the answer on the next slide. Do this for each question in the assessment. Good luck.